This world is quiet now. The day has folded itself away, and the great canvas of night is unrolled, stretching from horizon to horizon. If you step outside and look up where the light of the city cannot reach, you will see it. A soft, luminous streak, a hazy ribbon of white light arching across the sky. This is the Milky Way, our home, our cosmic island. And tonight, we are going to travel its endless pathways. Imagine, if you will, that this river of light is not made of water, but of stardust, an ancient stream of billions upon billions of stars, so numerous and so distant that their individual lights blend into one glorious milky haze. That is why we call it the Milky Way, a celestial road of light. A journey begins not with a rocket, but with a whisper of thought. In the blink of an eye, we float far above the tiny blue marble we call Earth. We see the sun, a star we know so well, but here, it is just one of the hundreds of billions of stars in this galaxy. It's like a single grain of sand on a beach that never ends. We live in the suburbs of the Milky Way, about 27,000 light years away from the bustling, brilliant center. We are nestled gently on one of its four main spiral arms, a quiet little neighborhood in a colossal city. This Milky Way is a barred spiral galaxy, a name that sounds grand and a little bit like a dance. Picture a giant, flat, spinning disk, like a colossal cosmic frisbee, about 100,000 light years across. A light year is the distance light travels in 1 year. So imagine the sheer scale. It would take you 100,000 years, traveling at the fastest speed possible in the universe, just to cross our galaxy. At its center is a bar-shaped structure of stars, which is why it's called barred. And from this central bar, beautiful, swirling arms spiral outwards, like the pinwheels of a celestial garden. This galaxy is old, so very old. It was born almost at the beginning of time itself, approximately 13.6 billion years ago. For comparison, our sun is only about 4.6 billion years old. The Milky Way has been turning, growing, and dancing in the darkness for eons. Everything you see, every star, every cloud of gas, every speck of cosmic dust is bound together by a force that is the very fabric of the universe. Gravity. A solar system is not stationary. It's rushing through space at an incredible speed, about 515,000 miles per hour, 828,000 /. Even at this breathtaking speed, it takes us about 230 million years to complete just one single lap around the galactic center. The last time our sun was in this exact spot on its galactic journey, the Earth was ruled by the dinosaurs. Imagine that. You are traveling on a starship we call Earth, and your journey has been going on for a very, very long time. But what lies at the heart of this ancient, spinning city? That is the secret of the next part of our journey. As our cosmic vessel drifts closer to the center of the Milky Way, the scenery changes dramatically. We are leaving the tranquil, starry suburbs and heading straight for the dazzling, chaotic metropolis. This is where the action is, a place of intense gravity, brilliant light and profound mystery. Its galactic center is a region known as the bulge. Imagine a colossal, luminous sphere of stars, densely packed together like bees in a hive. In our neighborhood, stars are separated by light years in the bulge. They are sometimes only light weeks or even light days apart. The sheer density here is staggering. It is estimated that within this central region, there are at least 10 billion stars, all whirling in a tight, gravitational dance. The light would be overwhelmingly bright, bathing every world in eternal twilight. Stars in the bulge are generally older and redder than the young, blue stars we find in the spiral arms. These are the ancient citizens of the galaxy, carrying the wisdom of nearly 14 billion years of existence. Their paths are not the gentle, looping orbits of our sun, but complex, elliptical trajectories, swooping up and down through the plane of the galaxy. It is a three-dimensional ballet, choreographed by immense gravitational forces. As we peer into the deepest core of the bulge, we encounter the ultimate secret of the Milky Way, a behemoth of cosmic nature, an entity that warps space-time itself. This is Sagittarius A, pronounced A star, the supermassive black hole that anchors our entire galaxy. A black hole is not a void. It is the ultimate concentration of matter and gravity. Sagittarius A has a mass estimated to be over 4 million times that of our Sun, compressed into a space smaller than the orbit of Mercury. It is a region of absolute darkness because its gravitational pull is so powerful that nothing, not even light, can escape once it crosses the event horizon. It is the silent, invisible conductor of our galaxy. Its enormous mass dictating the movement of everything around it. It doesn't suck things in from across the galaxy, but its gravity rules the immediate vicinity. We see its presence not by the black hole itself, but by the furious dance of stars orbiting it at breakneck speeds. Imagine a star moving at over 17 million miles per hour, 27 million km/h, completing an orbit around the black hole in just 16 years. These are the captured dancers, showing us the invisible king. This region immediately surrounding Sagittarius A is enveloped by immense clouds of gas and dust. These clouds are not the gentle, wispy forms we see in the night sky. They are the stellar nurseries, colossal reservoirs of hydrogen and helium gas, where new stars are constantly being born. The intense radiation from the nearby, massive stars heats this gas to scorching temperatures, making the core a vibrant, energetic, and volatile place. New suns ignite in fiery bursts, live their brilliant, short lives, and often end in spectacular supernovae, explosions that seed the galaxy with the heavier elements necessary for planets, and eventually, life. Every atom of iron in your blood, every bit of carbon in your body, was forged in the heart of an ancient star that lived and died in a place like this. The center of the galaxy is also a major source of gamma rays and X-rays, high-energy radiation generated by cosmic rays colliding with gas. and by matter spiraling violently towards the event horizon of the supermassive black hole. It is a region of creation and destruction, a place of raw, untamed cosmic power. Yet, despite all this turmoil and fire, the core of the galaxy is also where the most magnificent structures can be found. As we begin our slow turn outward, we see giant, symmetrical structures extending for thousands of light years above and below the galactic plane. These are the Fermi bubbles, two colossal lobes of high-energy gas inflated by past activity from the central black hole. They are a testament to the fact that the life of a galaxy is anything but static. We'll leave the bulge, our minds reeling from the sheer density and power we have witnessed. Ahead of us lies the vast expanse of the galactic disk itself, the quiet territory between the spiral arms and the final, beautiful destination of our journey. Leaving the blazing heart of the bulge, we coast back out into the broad, flat disk of the Milky Way, where our own solar system makes its home. This is the realm of the spiral arms, the galaxy's most distinctive and beautiful feature. These arms are not rigid structures, but rather waves of density, much like a traffic jam on a cosmic highway, where stars, gas, and dust bunch up, triggering intense periods of star formation. A galaxy has 4 major arms and several minor spurs. We reside in a smaller branch known as the Orion Arm, or Orion Cygnus Arm, nestled between the larger Perseus Arm and the Scutum Centaurus Arm. The stars in these arms are mostly population-eye stars, young, hot, and rich in heavier elements that were forged by previous generations of dying stars. This makes the spiral arms the most fertile grounds for the formation of new, rocky planets like Earth. As we traverse the space between the arms, known as the interim regions, we notice that the density of stars decreases, but the universe is far from empty. Here, we encounter vast, cold, and beautiful structures, the molecular clouds. These are gigantic, dark nebulae, often thousands of light years across, composed primarily of molecular hydrogen and dust. They are the galaxy's raw material reserves. When a shockwave from a nearby supernova or the pressure of a density wave hits one of these clouds, it collapses under its own gravity. Thus, collapse leads to the birth of a stellar nursery. We see luminous examples of this process, giant, glowing clouds like the Orion Nebula, where hundreds of new stars are igniting simultaneously. These newborn stars, often referred to as O and B type stars, are massive, blue, and incredibly hot. They burn through their fuel quickly, blazing fiercely for only a few million years. But their powerful ultraviolet light carves out magnificent, colorful canyons in the surrounding gas and illuminates the vast structures we see through telescopes. It is a spectacle of violent creation. The journey through the spiral arms is also a journey through cosmic ecology. Every time a massive star dies in a supernova explosion, it scatters the heavy elements created in its core, iron, gold, uranium, out into the surrounding space. This material mixes with the cold molecular clouds. This process, known as chemical enrichment, is what makes the newer generations of stars, like our Sun, able to form planets composed of rock and metal. Without these cosmic recycling events, the Earth could not exist. The very ground beneath your feet is truly made of stardust, recycled from stars that died billions of years ago. It is in these arms that we also find the most dramatic examples of open clusters, groups of hundreds or thousands of young stars that were all born at the same time and are loosely bound by gravity. They are like cosmic families, slowly drifting apart as they orbit the galactic center. Over billions of years, the gravitational influence of the massive galaxy itself pulls these clusters apart, scattering their stars to join the general stellar population of the spiral arms. We realize that the Milky Way is not a static picture, but a dynamic, churning ecosystem. Gas flows in from the outer reaches. Stars are born, stars die. Elements are recycled, and everything spirals around the central black hole in a grand, perpetual dance. But what exists beyond the comforting brightness of the spiral arms, and what is the ultimate fate of our galaxy? Our final two parts will take us there. Its halo and the dark matter veil. A journey now takes us up and out of the flat galactic disk into the vast spherical volume that surrounds the Milky Way, the galactic halo. This region is entirely different. It is sparse, ancient, and utterly dominated by the unseen. This halo is a gigantic, diffuse sphere of space that extends for hundreds of thousands of light years in every direction. It contains only a tiny fraction of the galaxy's visible mass, and what visible material it does hold is incredibly old. The most prominent visible structures here are the globular clusters. These are dense, ancient balls of tens of thousands to millions of stars, packed tightly together. Unlike the open clusters in the disk, globular clusters are made of population II stars, very old stars that formed when the galaxy was young, and thus they are poor in heavier elements. They orbit the galactic center in highly elliptical, sometimes chaotic paths, relics of the Milky Way's earliest days. They are like living fossils, preserving the conditions of the nascent universe. Thus, globular clusters are the remnants of ancient, smaller galaxies that the Milky Way has cannibalized over billions of years. Our giant galaxy is not a solitary entity. It grows by merging with and absorbing its smaller neighbors. We can observe streams of stars in the halo that were pulled out of these dwarf galaxies by the Milky Way's powerful gravity, stretching across space like ethereal ribbons. This galactic cannibalism is a slow, steady process that continues today. But the most mysterious and crucial component of the halo is something we cannot see at all: dark matter. This invisible substance is the gravitational backbone of the Milky Way. Scientists estimate that the visible matter, all the stars, planets, gas, and dust, makes up only about 15% of the galaxy's total mass. The remaining 85% is this elusive dark matter. When no dark matter exists only through its gravitational effect. If the Milky Way were made only of the visible stars and gas, its spiral arms would spin much slower at the edges than they do. Instead, the outer regions of the galaxy rotate almost as fast as the inner regions, a phenomenon that can only be explained by a massive, invisible, spherical cloud of matter, the dark matter halo, enveloping the entire galaxy. This invisible mass provides the extra gravitational pull needed to keep the outer stars in their orbits. Imagine trying to look through a thick, invisible, clear jelly that fills a vast space. You cannot see the jelly, but you can see how it warps the path of the stars passing through it. Dark matter is the scaffold upon which the visible galaxy is built. It is the hidden architecture of the cosmos, dictating the shape and destiny of the Milky Way. Though we do not yet know what dark matter is made of, its gravitational presence is undeniable and essential to our existence. Beyond the halo, the space is not empty, but filled with the diffuse, intergalactic medium, where we begin to see the first signs of our galactic neighbors. Our final chapter will bring us to the future of the Milky Way and its colossal collision course. Destina and the cosmic shore, a magnificent journey now reaches its conclusion, looking out from the perimeter of the halo and into the immense cosmic ocean where other galaxies drift. The Milky Way is part of a larger, gravitationally bound group called the Local Group, which contains over 50 galaxies, most of them small dwarf galaxies, but dominated by two giants, our own Milky Way and the majestic Andromeda galaxy. M31. Andromeda is a galaxy very similar to ours, a vast spiral, and it is the largest member of the Local Group. It is currently located about 2.5 million light-years away from us, making it the most distant object visible to the naked eye. But this distance is shrinking rapidly. The ultimate destiny of the Milky Way is a spectacular, inevitable event, a galactic collision with Andromeda. The two colossal galaxies are rushing towards each other at a speed of about 250,000 miles per hour, 402,000 km/h. In approximately 4.5 billion years, their two gravitational fields will lock, and the long process of merging will begin. Despite the name collision, it will not be a sudden, violent crash of stars, because the stars themselves are so incredibly far apart. The chances of our sun physically hitting another star are astronomically small. Instead, the two spiral galaxies will pass through each other, their gravitational fields ripping and tearing at each other's structure. The beautiful spiral arms will be destroyed, and over a period of hundreds of millions of years, the two galaxies will coalesce into a single, much larger, more spherical entity known as an elliptical galaxy. This future galaxy has already been given a name, Milkomeda. Long after this cosmic merger, the universe will continue to expand, carrying other galaxies further and further away from Milkomeda. Eventually, As the cosmos ages, our merged galaxy will be one of the last visible luminous islands in a deep sea of universal darkness. As we turn our gaze back towards Earth, rushing at incredible speed on its long galactic orbit, we realize that the Milky Way is more than just a collection of stars. It is a home, a dynamic entity, an active participant in the story of the universe. It is a living laboratory where creation and destruction occur on a scale beyond human comprehension. We are small, but we are made of its stardust, and our planet rides securely within its arms. Now, as the vast, luminous band of light stretches over your night sky, you know its secrets: the quiet spiral arms, the ancient globular clusters, the hidden veil of dark matter, and the fiery heart ruled by a black hole. Let the light of this great, ancient river of stars watch over you as you rest. Sleep well, knowing you are a part of the grandest story of all.